All right, hello everyone. Now we are going to look at how do we determine the age of a tree. This is a bit trickier, but it still can be done. It does involve some math, however. We'll get into that in a bit. So you probably know at least one way to measure the age of a tree, and that is to use something like this, which would be a slice of a tree, or if you cut the tree down, you can see, if you look at the trunk, the center of the tree, and then you can just count how many rings there are on the tree trunk, because a tree will add usually one ring every year. So you simply count how many rings there are, and that tells you how many um, years old the tree is. It looks, in a drawing, it would look something like this. So you have a drawing, and all we need to do now is count how many rings there are. This outer ring here would be this year's growth, where the bark is just below the bark. That's the only part of the tree that's alive. And then all the rest of this part of the trunk is dead wood, but it's added a ring every year, a ring of new growth. So we just need to count how many rings there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There are 25 rings. And that tells us then that this tree is 25 years old. Piece of cake, right? Downside of that is we had to cut the tree down in order to figure that out. There is another way to do it, and that way involves using a tool that if you're a forester, somebody who studies trees, or you're a scientist studying trees, you'd use this a lot. This is called an increment borer, and what it does is it drills a hole into the side of the tree. And then once you've drilled that hole, you can insert a metal extractor, and it will pull out a core of the tree. And then that core you can look at, and you can count the rings in the core. That way you've only drilled a small hole in the side of the tree and you haven't killed it, right? From these cores, from taking lots and lots of cores, one of the things that foresters have learned is how quickly each species of tree tends to grow. And that's using that information is how we can estimate pretty well the age of the tree without having to drill a hole in it and allow a place for bugs and other things to get into the center of the tree, or to cut the tree down and kill it. This is where our math comes in. All right, so let's look at this math a little bit. The math isn't terribly complicated. All we need to know is a little bit about the geometry of a circle. I mentioned earlier that what we need to determine in order to figure out its age is what is this distance across the middle of the tree, because the tree grows bigger and bigger and bigger and bigger across the center as it gets older, right? So if we can determine how fast it takes to get to a certain size, how many years it takes to get to a certain size, we can figure out how old the tree is. We'll get to that in a sec. First, let's look at our geometry of our circle. So we mentioned the diameter. That's this distance, this red line across the center of a circle. The other idea is the circumference of the circle, which is the same idea as a perimeter of a square. It's the distance around the outside of the circle. So if you had a little guy walking across the outside of the circle, that would be its circumference. What is really awesome about circles, no matter how big, size of the universe, size of the solar system, massive, massive circle, or really teeny, like the circle that's the tip of your pencil point. No matter how big or how small, the relationship between the distance around the outside, the circumference, and the distance across the center of that circle, the diameter, will be the same. It never changes, no matter how big the circle is. And that relationship is defined by a number called a constant, and in this case, that constant has a special name. It's called pi. Yeah, you've heard of it, Pi Day, right? March 14th, because the number, or the constant, that is pi, or we round it up to this number, is 3.14. So 3.14 is the number that represents the relationship between the distance around the outside of a circle to the distance across the center of a circle. Basically, the way it works, if we want to know the diameter, all it is the distance around the outside of the circle divided by pi will equal the diameter. Pi is 3.14. So if we can measure the distance around the outside of our circle, which we can easily do out in our tree, right? Strap a tape measure around the outside of the tree. If we can divide that number, whatever we get, by pi, by 3.14, that'll tell us the distance across the center, and we can do that without having to shove a ruler through the tree. Pretty cool, huh? So to make this a little faster and easier, I'm not going to show you on film, but I already went out and I took a tape measure and I strapped it around the outside of the tree and I measured the circumference of the same loblolly pine tree that we used when we were looking at the crown spread. And I did this 4.5 feet above the ground. That's the standard height where you want to measure the circumference of the tree. So I measured the circumference 4.5 feet above the ground and it was 94 inches. So we remember then that if we have our circumference is 94 inches and we divide that by pi, that will give us our diameter, which is what we need to know in order to determine the age of the tree. So let's do that with a calculator real quick, because calculators are wonderful things, right? All right, so let's go to our calculator. So we said it was 94 inches across around the outside. The circumference of the tree was 94, and we're going to divide that by pi. So 94 divided by 3.14, which is pi, equals 29.93 inches in diameter. So let's make this, instead of 29.9, let's just call it 30, make our life a little easier, right? So let's say then that the diameter of our tree, distance across the center of the circle here, the diameter of our tree will be 30 inches. Yeah, make sense? Cool. So now the next step, little bit trickier, is we need to do another set of math. So we know it's 30 inches in diameter. What we need to look at now is, how do we determine how old the tree is? Because foresters have used things like that borer tool many times, and they've determined the age of lots and lots of trees, they can figure out pretty much how quickly different kinds of trees grow, and different species of trees, different types of trees, will grow at different rates. And they determined what those rates are, and those are called factors, age factors. So what we need to do, and this might be the hardest part of this whole assignment, is know what kind of tree we're looking at, or roughly, in general. Is it an oak? Is it a maple? Is it a pine tree? Let's say our tree that we looked at was a loblolly pine. So if we go down and we find loblolly pine, and we look at what the tree factor is, it's 2, which means that's the rate at which the tree grows. Different species of trees grow at different rates. Some grow really fast, some grow really slow. And because foresters and scientists who study trees have measured the age directly of so many different trees, they can pretty much figure out these numbers. And all we do is we multiply the diameter of the tree, whatever that was, times the age factor, and that will tell us how old the tree is. So we know then that our tree was what? It was 30 inches in diameter. So we multiply 30 times, our kind of tree was a loblolly pine tree. So we go to a loblolly pine tree, the factor is 2. It was 30 inches across in diameter. So 30 times 2 equals 60, and that tells us that the age of our tree is 60 years old.